Hi, this is Janine Cloud with Family Tree DNA, and the title of this talk is Which DNA Test is Best for Me? Choosing the right DNA test for your situation. All the time we get questions about which test is best to buy. Someone will come up and say, I want to buy a DNA test. Which one is the best? Because we have this pretty display. We have paternal ancestry, family ancestry, maternal ancestry, Y-DNA, family finder, mtDNA. What does what? Which one is going to be the one that is going to solve your problem? Well, that's kind of like asking which tool is best. Hammer, saw, depends on what you're doing. Are you hammering nails? Are you cutting wood? What are you doing? What are your goals? So it depends. Look at your genealogical goals the same way. Why are you testing? What kind of questions are you trying to answer? Are you looking for a particular ancestral origin? Are you looking for a specific person? Are you looking for someone that lived several generations ago? That's an important consideration because autosomal tests go back a certain way. Each one has its own pluses and minuses. So let's look at some of those advantages and some of the disadvantages of the test. Now we have nuclear DNA and mtDNA. The nuclear DNA is in, as it would sound, in the nucleus of the cell. That's your autosomes, your xDNA, your Y-DNA. And then there's mitochondrial DNA, which is outside of the nucleus of the cell. So it behaves differently than the DNA that's in the nucleus of the cell. Now we have Genetics 101 here, essentially. Everyone gets 22 sets of autosomes and a set of sex chromosomes from your parents. You get the XY if you're a male, XX if you're a female. And that's important when you're looking at your genealogical problems. You're puzzled what you're trying to solve as to which kind of test you're going to get. The options include autosomal. At Family Tree DNA, we call it Family Finder, and that includes the X chromosome. I believe most of the autosomal tests on the market today do include the X chromosome as part of that. But if you've tested it in another company, you can transfer to Family Tree DNA. And then we have mitochondrial DNA, Y-DNA. The entry level is a 37 marker test, and the 111 markers will give you a little more refined match results because the more markers that you match on, the more likely it is that it's recent. And then we have the exploratory Big Y test, which sequences a big chunk of the Y chromosome. It gives you 700 STRs plus haplogroup placement, block tree placement, and it helps pinpoint your family line SNP mutations on the huge haplotree pedigree of mankind. Now, autosomal DNA is the DNA that you get from each parent, 50% from each parent. You get that half of your autosomes from each one, and they got theirs from their parents and their parents, etc. And so it divides in half as it goes back each generation. So the chances of you getting DNA from one of those particular ancestors in a particular generation decreases with each one you go back. Now, keep in mind that siblings receive 50% from each parent, but not the same 50%. So be sure to test your siblings, but also consider that when you're looking at the DNA that was inherited by that ancestor that you're trying to reach, if the ones that came in between, they may not have gotten as much from a particular ancestor and not have had as much to pass down. So it can be kind of complicated, but the moral of the story is to test more people. Now, each generation does carry less of that ancestor's DNA, the autosomal DNA. At 7 generations, it's less than 1%. And so, the chances are good that you're going to miss out on a few of those 5th or 6th great grandparents. And it's not inherited in exact ratios. It's not like you get a certain percentage from each one. It's not the mathematical division there. It's something called random recombination, which is like shuffling together a couple of decks of cards and dealing out a hand. And each time you shuffle that deck of cards together, it gets more and more and more combined so that the chunks are smaller. Now, an example of how random recombination works, I have a perfect one with my family. I have cousin Roy. His second great-grandfather and my third great-grandfather were brothers. Now, they married a set of sisters, so their children did have additional DNA that should make them show up more. But cousin Roy tested not long after I started working for Family Tree DNA back in 2011, and he and I didn't match, which was disappointing, but not particularly surprising considering how long ago that connection was. Well, then I tested my uncles, a couple of my uncles, and he ended up matching both of them. That wasn't too surprising since that's another generation back. And, he matched them at different levels, actually. He matched them at different predicted relationship levels. And then I had four first cousins who tested. 3 of them I recruited. 1 of them tested her on her own. Every single one of those, and in fact, one of the grown sons of one of those cousins tested, and he matched him. Cousin Roy matched all of those people, but not me. And he doesn't match either of my half-siblings, my father's children. This is all on my dad's side. So, me and my half-siblings don't match cousin Roy. Everybody else does. Now, the rest of the relationships are the way they should be. So there's no hanky-panky going on there. I mean, there might have been, but we didn't know about it, and it didn't show up in the DNA. Everybody's got the right relationships. It's just that apparently my dad didn't inherit enough of that connection, of that shared DNA to pass to his children. So if I had stopped with me or my half-siblings, then I would not have found that connection. If I had been actually looking for cousin Roy, I wouldn't have found him because it took other siblings to get that connection. Now, xDNA is included with the autosomal test, and it's a unique inheritance path. So since men get 1 X chromosome, it's from their mom, you know that any X match comes from his maternal side. Now, it doesn't necessarily mean that match is on their maternal side, but if it's the male's maternal side. Now, it's typically a combination of both of her X chromosomes. And then with females, we get 1 from each parent, one from dad that he got from his mom, and then 1 that's recombined from mom's X chromosomes. We get 1 that's mixed together from both of the ones that mom had. And again, random recombination comes into the picture. It mixes together, only it's a little bit odd, like I said, because it's of the inheritance pattern, and it's not as complete a recombination as autosomal DNA is. Now, mitochondrial DNA is pretty simple. It follows that direct maternal line, your mother's 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 line. It goes back thousands of years and gives you a haplogroup. Both men and women can test it. Everybody has mitochondrial DNA. It's just that it's only that direct maternal line. So if you test your father, you can get your father's maternal mtDNA, his maternal line, but it's not going to be your maternal line. So matches share a maternal ancestor at some point in history, and it doesn't divide out like autosomal does. It doesn't go back, each generation doesn't get less and less. It stays the same. It does have some limitations, though, because it's not going to tell you anything about male ancestors, even though men can take the test. It only traces that maternal line. So if you're looking for a male at any point beyond the current generation, mtDNA is not the test to take. It does change pretty slowly, and determining when matches are connected can be kind of difficult. Some of that has to do with the size of the database, the number of people who've tested. Even though mtDNA has the largest mtDNA database in the world, it's still fairly small compared to the number of maternal connections there could be. Now, it may require you to test more than one person to solve a specific problem on a specific line. You may have to use more than one mitochondrial to be able to rule in or rule out a particular connection. The good news is there is no random recombination, though. There's no mixing together. There's no guessing as to who it came from. Now, Y-DNA comes from the paternal line, your father's 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 line. It also provides a haplogroup. Y-DNA gives that those paternal origins. With that haplogroup, you can tell what part of the world they came from. It gives matches who share a paternal ancestor at some point in history, and it could potentially point to a surname. With my uncle's tests, he matches quite a few clouds. There are some non-cloud matches as well. Sometimes they can be scattered. It can be all kinds of names. Sometimes it can be overwhelming. I remember clearly at one point talking to a guy who was looking for his matches with his surname, and he had happened to match Montgomery's, and Montgomery's have done a lot of testing, and all his matches were Montgomery's, and I had to gently tell him that at some point his line was Montgomery, because there was at every single level. So it can potentially provide a surname. It also does not divide, and it does have limitations. Only men can test, since only men have the Y chromosome. And it doesn't tell you anything about female ancestors. So when you're looking at female ancestors and you're starting, you mention a male, you've gone off that female line. You're talking about a male ancestor and then you start talking about a female, then you've gone off the Y line. It traces that direct paternal line, but it can't distinguish between brothers within the last 200 or 300 years. There has to have been enough time for there to have been mutations, SNPs to form from those lines to be able to distinguish whether you descended from one brother or not. You can't take a Y-DNA test and know which of two immediate brothers was your father. But there is no random recombination. It's not blended together, so you don't have to be concerned with that. It is just that unbroken paternal line. Now, some examples of this, some ways of looking at information to see what's going to work for you. Now, Jenny Hobbs Stidham was her married name. She's a brick wall for me. I can't get past her. She's on my father's direct maternal line, born in Georgia in 1830. And she might have been Cherokee, I thought, because Jenny is a really common nickname for Cherokee women, because the way that the Cherokee language is, one of the common syllables is pronounced J. And so a lot of women went by Jenny because it went with the language. Now, her mitochondrial DNA, if she were native, would show those native origins. You can see here's the line, the orange going up from my dad to his mother to his mother to his mother to Jenny back in 1830. And that would have still been in the right time frame. That was before the removal, so it was possible. And so who could I get to test for that? I can't test for it, obviously, because that's not my maternal line. My dad passed away before I started work, or not long after I started working with the company. So my uncle did Y-DNA testing for me. So he would have been a good candidate. His siblings, his sisters with daughters. His sister here has daughters who have daughters. And so anyone in this picture over the age of 13 would be a good candidate. And then those daughters' children on down the line. Now, here's another puzzle. So my mother's maiden name was White. did her father descend from the Mayflower Whites? Well, Y-DNA would be the best tool to connect that, because we do have a project with the General Society of Mayflower Descendants who do have some of the signatures and who are actively researching Mayflower descendants. So, I can't do Y-DNA for anything, much less for my mother's side. So who would be potential candidates? So here's my brick wall. I go from my mom to her dad, to her dad, to her dad, and I get back to Alexander White, and I hit a brick wall. Well, I could go with my grandfather, but he died not long after I was born. My mother's older brother and his son, they both died. I could see whether he had any sons. I have one cousin that's living that could be a target, and if he had any sons. I have one that's living, but he refused, and if he had any sons, his sons might do it. My mother's other brother, he died, and he had all daughters. One died early on. I kind of feel odd calling him uncle because he died when he was 14 years old or something. So that feels kind of weird. But he didn't have any children. Now, my grandfather's brother had a son, but he died in 1976. Now, if he had any sons, it might work. My grandfather's other brother, Charlie, who had a son, he died in 2013. Now, he had a son that's living, so he would be a target. And so I just have to get with my cousins to target those people to find that out. And then I have Jane Wallace, who was born in 1816 in Georgia, and she was my maternal grandmother's paternal grandmother. I don't know who her father was, who her mother was. So could I use Y? Well, I don't know that she had any brothers. I don't know anything else about her, so I don't know any males to draw any lines to. Could I use mtDNA? Well, obviously not on me or on my dad or on my mom. I don't know anything. She had 5 daughters. I could try to track down those daughters and see if they had daughters. Autosomal DNA, it's a little iffy, but it's possible. So check my matches, check my maternal cousin's matches to see who has Wallace matches, and that might provide some twigs. Might be one of them would be a Y candidate. So here's my mom, Maggie Edry Cloud, and this is her mom, Mary Jane, her father, Thomas Jefferson Barnett, and his mother. So it's really clear right off that this is not a straight line. So getting a Y-DNA or an mtDNA test have to take to get the right people to do them. And so autosomal DNA is really the only solution to start with. So I look at my matches and I go into my Family Finder matches and I search for Wallace, and I've got a tree attached with my closest relatives there. So our system has divided them into maternal and paternal connections, and there's a couple that are on both sides. And I look through all these, and the top ones here are all female. I have one that's male, so he's my target since his surname is Wallace. He's connected on my maternal side. He's a pretty distant relative. We only share 9 centimorgans, which is almost at the very lowest end of being shared. So that would support it being a pretty far back cousin. So he would be a candidate to see if he's done Y testing, to try to get with him on his tree to see if they can find information there. And so, I did that exact search there. And so you can check all databases. I go into matches in other tests, find Wallace's there, and see who might be connected there. And then you can use those matches as candidates. You check by the name, ancestral surname in all databases, look for the tree, ask for their tree. When you do that, make sure, if you're going to write to your matches, make sure that you use proper email etiquette when it comes to writing about DNA tests. Lots of people manage more than one test, and if you just write and say, hey, we match, how are we related, the chances of them answering that email are kind of slim, because they're going to need a little more information than that. So always say, hey, I'm so and so, and I'm looking, the test is under this name, and the match that I'm looking at is, this other name here, and you're listed as the kit manager. Your email is listed with the kit. Here's what I know. Can we compare notes? Because I've had that work. I've had someone send me information, and I was able to make connections that way pretty simply. Sometimes it takes a little bit of work. Sometimes it takes a lot of work. But without that information, I'm a lot less likely to take time to respond to somebody who doesn't give me the right information. Now, if you're lucky, that person's already done the test that you need. So in summary, remember to figure out who you're trying to connect to. Who is it you're trying to reach? Write it down, draw pictures, pull out your pedigree chart, draw those straight lines. You may have to do some more paper trail research to find descendants who might be candidates. It may take more than one test. It may take more than one test type. And it may take more than one tester to get that destination. But if you think about it, like, how many times have you looked through census records and only looked at one census and found what you wanted? How many times have you looked through tax records and only looked in one set and found what you wanted? DNA testing is no different from that, in that you may have to sort through a bit of information. You may have to purchase additional information to be able to get what you're looking for. Thank you for your attention. If you're watching this during Roots Tech, visit the virtual booth, or you can also write to groups@ftdna.com. If you're watching this after the conference is over, just write to groups@ftdna.com, and we'll be happy to assist you.